Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss about the Joule's experiment, work and heat. So Joule's experiment, work, heat and internal energy, and we will study that what is the relation between work and heat and internal energy. So first of all we will discuss the Joule's experiment. Joule was a scientist. He performed some experiment using various liquid. So he took various beakers. Suppose this beaker, this one, and this one. So he took various liquids like water 1 gram H2O, 1 gram oil, 1 gram of mercury. So he took 1 gram of water, 1 gram of oil, 1 gram of mercury and are in various beakers. In these beakers, the initial temperature of these liquid were 15 degrees centigrade. 15, 81 of this liquid was 15. The initial temperature was 15. The initial temperature was 15 for mercury also. So he took various beakers. He took 1 kilogram of various liquids like water, oil and mercury, and he put thermometer into these beakers, and he noted the temperature of these 3 beakers which was 15 degrees centigrade for every liquid. 15 degrees centigrade initial temperature. Then he put a stirrer into these beakers. This stirrer, and this stirrer. Then he applied this. Remember that the beakers which he selected were insulated. So these are the insulated beakers. So he applied some insulating material around the beaker, that neither heat comes into the beaker nor heat get out from the beaker. So these are the insulated beaker. The white one is the insulation. These are the insulated beaker. Insulated beakers. This one is also insulated beaker. This one is also insulated beaker. Then he put stirrers into these beakers. So this stirrer, and this stirrer. And then he applied some work to the stirrer to rotate the stirrer. So when the stirrer was rotating, in these 3 liquids, then it gives some heat to the liquids. This liquid, this liquid, this liquid. So first of all he took various beakers. He put 1 kilogram of water, oil and mercury into these 3 beakers. Then he recorded the temperature of these 3 beakers, which was 15 degrees centigrade for each beaker. Then he put stirrer into these 3 beakers, and then he started the stirrer in these 3 beakers. So after a certain time he noted the temperature of the 1 kilogram of water. The temperature he recorded was, suppose the temperature he recorded was Q2, and it was slightly increased, 16 degrees centigrade. Similarly, he started the stirrer in this solution, and after a certain time he noted the temperature. The recorded temperature he obtained was Q2 is equal to 16 degrees centigrade. Also he started this stirrer, and he noted the temperature which he recorded was Q2 is equal to 16. So after starting the stirrer, the temperature of this solution was increased. After starting the stirrer, this temperature of this solution was also increased to 16. This one was also increased to 16 degrees centigrade. So he noted that when we apply some work on the liquid, the temperature of the liquid was increased. So he said that when we applied external work on a system, then the temperature of the system increases. So Joule conclude from this experiment that when we apply some external work on a system, then this work increases the temperature of the system. So he said that the temperature of the various system was increased because of the work which we supplied to the various system. So he concluded that when we applied some external work to a system, then the temperature of the system will increase as well. This is because when we apply some work to the system, this work will convert it to the heat of the system. So this work, which is W, this is work of the stirrer, this is work of the stirrer. This is the work done by stirrer on this liquid. This W is the work done by stirrer on this oil. This W is the work done by stirrer on this water. So he said that the work done by stirrer on the various 1 kilogram of various liquid is equal to the heat produced in these system. So we conclude that the work done on this system is equal to the heat produced in this system. The work done on this system is equal to the heat produced in this system, which is Q, which is also Q, and the work done on this 1 kilogram mercury will be equal to the heat Q which produced in this beaker. So from this experiment we conclude that the work done is equal to the heat produced in the system. So this was a Joule experiment. Now if we, so from this experiment we conclude that the work which we done on the various system, which is work which done by the stirrer on this 1 kilogram mercury, on this 1 kilogram oil, and on this 1 kilogram water, is equal to the heat produced in these systems. So the work done on the system, the work done by stirrer on the systems is equal to the heat produced in these systems. So W is equal to Q. Now if someone is interested to remove the heat from this system, so suppose we are interested to remove heat from these systems, so first of all we will remove the insulating material from this beaker. So we remove the insulating material from this beaker, remove insulating material from this beaker, and also remove the insulating material from this beaker. So if someone is interested to remove heat from these beakers, so first of all we remove the insulating material from these beaker, then we put these beaker in a large beaker of liquid water. Similarly we put the second beaker in large beaker of cold water. Similarly we also put this beaker in large beaker of liquid water. So after removing the insulation, and when we put the small beaker in large beaker of cold water, then the heat which were produced in this system was converted into the, were transferred to the cold liquid water. So when we put this small beaker in this large beaker, then heat which produced in this system during the work of stirrer were transferred to the cold water. So the heat produced in the system was transferred to the cold water. Similarly the heat produced was converted to the was transferred to the liquid water. So the heat produced was transferred to the liquid water. So now if someone is interested to not release the heat of this system, then he will provide some insulation to these beaker. So if we apply insulation to these beaker, then the heat will not transfer to the liquid water. Now there is a question. That suppose this was one beaker this was one beaker, this was another beaker, this was the third beaker, equal beaker. Volume of beaker were equal. This was, suppose this was mercury, 1 kilogram mercury. This was 1 kilogram oil, and this was 1 kilogram of water. 1 kilogram of water, H2O, liquid water. This is 1 kilogram of mercury. Now we applied some insulation to this beaker. This was the stirrer. This is the stirrer. This is also the stirrer. We apply insulation to this beaker. This white shows the insulated beaker. To this beaker. Now, what will happen? So we apply some stirrer work, and the work of stirrer converted to the heat of this liquid. So due to the stirrer work, WWW work done by the stirrer on these liquids. So the work done by stirrer on these liquid will be equal to the change in energy of the beaker. So work done by stirrer number 1 on mercury will be equal to this work done by stirrer number 2 on the oil will be equal to W2 is equal to change in WK. Work done by stirrer number 3 on the 1 kilogram of water will be equal to change in Q3. So this is the work done equal to change in energy of the systems. So now these are the insulated beakers. These are the insulated beakers. Now when we apply work on these systems, then the temperature of this system increases, as we already discussed in this lecture. Now if we don't apply liquid water surrounding, now if there is no cool water surrounding this beaker, if the heat is not transferring from this beaker, small beaker to the large beaker, if there is no transfer of heat from small beaker toward the large beaker, then here the heat energy will transfer. As work is done on this system, if you don't provide liquid water around this beaker, so if you don't apply the cold water around the small beaker, then what will happen? This work, what will happen to this system? This work will increase the temperature of this system. This work will increase the temperature of this system. As we already discussed, this work will increase the temperature of this system. And the work which you done on the three systems, this system, for example, this is system 1, this is system 2, and this is system number 3. Work done on system number 1 by stirrer number 1 is equal to the change in the increase in energy of system number 1, which is equal to the increase in internal energy of system number 1. So what will happen if we don't apply cooling water around the small beaker? So in this case, the work supplied by the stirrer to the 1 kilogram of mercury will only increase the internal energy of the system, this system. Similarly, in this case, the work supplied by stirrer to this system will only increase the internal energy of system number 2. Similarly, the work supplied by stirrer number 3 to this system number 3 will equal to the increase in internal energy of this system number 3. So the work done by stirrer will be equal to increase in internal energy. Increase in internal energy. Now, what is internal energy? Internal energy is nothing but it is the motion. Nothing but it shows the motion of molecule, motion of atom or molecule of a system. So internal energy are nothing but these are only the so internal energy is denoted by U, and it is an extensive property of a system, and it shows the internal energy shows the motion of molecule in a motion of atom or molecules or ions in a system. Suppose this is a system, consists of these are the molecule in the system. Now if we increase the temperature, suppose it was at temperature T1, it was at 10 degrees centigrade. Now when we increase the temperature of this system, 1, 2, 3, 4, 5. Now if we increase the temperature of this system to 20 degrees centigrade, then the motion of this molecule will increases it. The motion of this molecule will increases. Motion of this molecule will increases it. So the internal energy of this system will increase. Suppose the internal energy of this was U1 and the internal energy at temperature 20 was U2. So the temperature at T is equal to 10 degree. The temperature of this system was U1. If T temperature is equal to 20 degree, the internal energy was increased to U2. So now similarly, if we decrease the temperature of this system, the internal energy of this system will decrease. So the internal energy of a system is nothing but it is a function of the motion of molecules. It shows the motion of molecules of a system. So the molecule in a system can show us three types of motion. One is translatory motion, one is the rotatory motion. So simple molecule like non-atomic molecule can show us translatory motion. Translatory motion means this molecule can move from this place to this place in linear motion. It can show us the vibratory motion. So suppose this is a molecule, it can come to this position, then it can come to this position, and it can come again to this position, it can come to this position, again it come to this position, again it can come to this position. So it shows the vibratory motion, and also it shows the rotatory motion. Suppose this is a molecule, it can show us circulatory type motion. So these three types of motion can be determined from the internal energy. So the internal energy of a system shows the translatory motion of molecule of a system. Similarly, it shows the internal energy shows the vibratory motion of molecule of a system. Suppose this is a system. Suppose this is a system. So similarly, the internal energy shows the rotatory motion of molecule of a system. So the internal energy is nothing but it is different from the external energy, like the potential energy and kinetic energy. Potential energy and kinetic energy are called external energy or mechanical energies, and the internal energy shows the internal or the molecular motion of molecule of a system. So this potential energy is denoted by mgh, and kinetic energy shows the half mv square. So both potential and kinetic energy are the extensive property of a system. Similarly, internal energy is also the extensive property of a system. But specific internal energy or the internal energy per unit mass or internal energy per unit mole, molar internal energy or specific internal energy are the intensive property. This was just introduction to the internal energy and Joule's experiment. Thank you very much for your attention.